Okay, welcome back. So we just took a look at this concept called a network resource pool, where you basically utilize system traffic reservations for virtual machines and draw from their reservation at the system reservation level to the resource pool level. So we had an example. We had two resource pool, one called pool A, one called pool B. When you create these pools, what you do is in the distributed switches edit settings page, right under the configuration tab, right underneath where you set system traffic, you set these network resource pools right here. You select you'd like to create a new pool and specify what size of a reservation you would like to grant to pool A. Now, before you go ahead and put in that you want 2 gigs of reservation, just verify up over here what you have available to work with. Since in the system traffic reservations, we defined a 500 megabit VM reservation. You have in a scenario where you have 5 hosts and 2 10 gig adapters per host, so that's 10 10 gig adapters. So 10 10 gig adapters is the aggregate of 5 gigabits of 500 megabits of VM reservations. So that's what you're seeing here. We're seeing 5 gigs of system traffic that has been reserved for VM traffic. Now I want to go ahead and create a resource pool. So here we're going to create pool A and use 2 gigabit from the 5 gigs that have been given to VMs at the system traffic level. So we're drawing down from the parent pool in this case. It'll then show us what our granted quota has been assigned. Once you do that, once you start assigning reservations to VMs, then you'll start seeing VM reservation being applied as well. So how do you do this? Well, for VMs, you also have the ability to set the same resource allocation settings. You can set for a VM their own share value, their own reservation, and their own limit. So the VMs will normally just inherit whatever their parent pool settings are for the shares, but for reservations, the VMs don't have one by default. So how would you apply one? You need to go into the VM's edit settings page and then expand on the network adapter in your VM's virtual hardware and find in the network adapter's expanded view their shares, their limits, and their reservations. Now, again, when it comes to VM reservations, a VM is only going to typically run on one physical adapter at any one time, right? Depending on what your teaming policy is. But in most cases, a VM is going to always run on one network adapter. So if the one network adapter has, or I should say, if every network adapter has a 500 megabit VM reservation, that's the most any one VM could ever reserve. So if you have this 500 megabit reservation, one VM could reserve up to 500 megs, or in the case, what do we have here? This is a slightly different example than what the slides have been referring to earlier. Here we have a case where there's just one host with one adapter. Not a very big environment here, but we have one host with one adapter. And so we have a 500 megabit reservation for system traffic, right, for VM traffic on system traffic levels. What this means is that the most you could ever reserve for any one of the VMs or any VMs altogether is 500 megabit. So in our case, in this example, the most we could reserve is that 500 megs. Here we are splitting up across 2 different virtual machines. One VM has been granted 200 megabit or 0.2 gigabit. The other VM has been granted 0.3 gigs or 300 megabit, right? So that the 2 VMs together cannot exceed 500 megabit. Now, going back to our previous example, what if we think about it in a larger scale scenario? Here we have a scenario where there's actually 10 adapters. We've got a whole set of virtual machines, but keep in mind, for any single adapter, it's still a 500 megabit reservation. So in our example, these 2 VMs that are part of the pool A, tenant A port group, that pool was able to guarantee for all the VMs as a group 2 gigabit. But these VMs, the most any one VM could reserve is actually 500 megs. Now also keep in mind, each VM is going to be able to run on one of these adapters here. So each VM could actually conceivably get 500 megabit reserve for him. This could get 500 megabit reserve for him. That means that these VMs are actually probably going to be running maybe on different hosts, right? Actually, one of the neat things about a distributed switch is it will actually work with DRS and place the VMs in the cluster based on their network reservation, in addition to their CPU and memory requirements too. Because normally that's what DRS does, right? It's looking at deciding where to place VMs based on CPU and memory. But once you have a distributed switch, especially set up with network reservations, DRS will place the VMs also depending on what their network reservation is. Here we have 3 VMs, and this pool has a 3 gig reservation. But remember, again, the VMs can only reserve up to 500 megs each, because that's the system reservation for VM traffic on each and every network adapter. So what will happen here, it's quite possible that all 5 of these VMs will be distributed across all 5 hosts, just so that each host has a network adapter able to grant the 500 megs to each VM that's on that one adapter, and then each host will have a spare adapter effectively for running other VMs and other non-reserved traffic. Right now, the VM that's running on one adapter will only be reserving 500 megs, so there's definitely more bandwidth on each adapter that can be used by other virtual machines. So that means that in our 10-a-day port group, we could definitely start up more VMs who also have a 500 megabit reservation, because remember, the pool actually has 2 gigs reserved, so he could conceivably have 4 VMs that have 500 megabits reserved for each VM. Or you can carve that up however you like. You could have far greater number of VMs with much smaller network reservations. Right? In the 10P port group, we could conceivably have 6 VMs with a 500 megabit reservation. And so those 6 VMs would be distributed across the cluster, or each VM basically gets their own network adapter. Now, other VMs will use and share those adapters, but nobody else can consume the guaranteed bandwidth that's been defined as each VM getting a 500 megabit reservation. So, these VMs can be set with much smaller reservations so that you can actually end up having quite a larger number of VMs running in each of the different resource pools. But as we can see here, Pool A gets a 2 gig reservation as a group. That's what the VMs altogether can reserve. And then all the VMs could reserve up to 3 gigs in Pool B. So again, those settings are in the VMs under the VMs Edit settings pages. But as far as setting up system traffic reservations and setting up network pool reservations, that's all being done in the network distributed switches configuration pages. All right, so I just mentioned we have this feature of network reservations as part of network I/O control, and this is all integrated with DRS. So when DRS does its placement policies, it's going to place the VMs in the cluster and across the cluster based on the CPU requirements the VMs might have, the memory requirements that they have, and also their network reservation. That's an important piece of how they integrate together with network I/O control and DRS. So here we happen to have a slightly different example. Here we have an example of network adapters that actually have a 600 megabit reservation, and that's across the entire cluster. And these VMs also have a 600 megabit reservation. So that means I can't run 3 VMs that each have a 600 megabit reservation on the same host. In fact, the animation will show you what happens here. When a third VM is powered on, it will essentially be placed on another host for us that can fulfill that 600 megabit reservation. Now, also, bandwidth and mission control is part of if you lose a network adapter. So what if we happen to have a case here where we have our 2 network adapters, each with a 600 megabit reservation across the cluster, and one of our network adapters fails? Well, that's going to basically mean that the VM that was using that network reservation on that network adapter, that VM can't run there any longer. And so now DRS will actually migrate the VM for us on the other host. Again, it's to fulfill the network reservations. Now, normally DRS doesn't really have to consider networking traffic when it makes its placement decisions unless there's a network reservation, like we have in these 2 considerations. HA also participates in this too, right? If a host fails, and so therefore the VMs will fail, in order for the VM to be powered on somewhere else in the cluster, the VM needs to be powered on a host that has also an available reservation. So it will only be able to be powered on if the surviving host has that network reservation available for them. So again, you want to be careful with these reservations, because if you set really large reservations, you're going to really limit the flexibility and the placement options that you'd have available for any type of virtual machines in your cluster. So as a review, let's take a look at an activity here. let's take a look at a similar scenario that we had talked about, but this time we're going to use some slightly different numbers. So notice already the network adapters that we're using are 40 gigabit adapters. So that means that we have an aggregate of, well, we've got 6 adapters and we have 40 gigs per adapter. So that's 240 gigabits of aggregate bandwidth. We've set some system reservations for management traffic at 4 gigs per 40 gig adapter. We've got a system traffic reservation for iSCSI traffic at 12 gigabits per adapter. And then for VM traffic, we've got 8 gigs reserved per adapter. So again, remember that aggregates across all the adapters. So we have 8 gigs reserved per adapter. We have 6 total adapters. We really have 48 gigabits of reserved VM traffic, right? So now let's look at what the exercise wants us to do. It says we want to guarantee that VMs connected to a distributed port group, we'll call it Prod 1, can access 25% of the available reserved bandwidth for VM traffic. Use the bandwidth reservation information in the example to answer the following question, right? What must you configure to provide the appropriate bandwidth in the VMs in Prod 1? And that means we have to do a little bit of math here, doesn't it? We have, remember, 8 gig VM reservation as a system traffic reservation, and that aggregates across all 6 of our adapters. So we have 48 gigabits of reserved VM traffic. The goal here is to let a port group called Prod 1 to be able to get 25% of that reserved bandwidth for our VMs. So what's 25% of a 48 gigabit reservation? Well, that's a quarter of that, right? A quarter of 48 gigs is 12 gigs. So we want to make sure that out of those 48 gigabits of reserve bandwidth for VMs, we want to create a new resource pool that Prod 1 can be associated with that's going to be able to guarantee 12 gigabits for that. So that's basically what we need to do here. We need to create a network resource pool that we can assign to Prod 1 that's going to get a network reservation of 12 gigs. And sure enough, that's exactly what we have us do here. We have our 48 gigabit of reserved VM traffic, and then we create a new network pool, right? Some pool for Prod 1 that gets a 12 gig reservation so that we can then assign that pool to the port group called Prod 1. And now our VMs, of course, the most any one VM could reserve is how much? The most any one VM could reserve is 8 gigs. Remember, that's what our system reservation is on each adapter. But all the VMs in the group can reserve up to 12 gigs. So that's not very much bandwidth compared to if we were to give every VM 8 gigs, well, then that's going to use it up very quickly. So here we have 3 VMs. All 3 together can reserve as a group up to 12 gigs. So maybe that's 4 gigabits each for that one port group, right? We might have another port group that is also using some other portion of that 48 gigabit VM reservation. So that was a look at network out of control in vSphere 6 and above, right? That happens to be network out of control version 3, which is what we still have in vSphere 7. We showed you how network out of control enhances performance, basically by equalizing traffic by default. Describe how to use network out of control, allocate bandwidth to different system traffic so that you can set different settings on a per traffic type setting. This is at your system bandwidth level, and then we can use network out of control to allocate bandwidth to our virtual machines, specifically drilling down to the VMs at its setting page. So that includes our network out of control lesson. Coming up next, we'll take a look at the remaining features that we'd like to show you with distributed switches. So we'll see you in the next lesson.